Okay, welcome to Chapter 10, Section 1 and part of Section 2. Today's topics are going to be inscribed quadrilaterals and arc length. So let us start with inscribed quadrilaterals. In other words, inscribed means inside a circle. Each vertex, F, R, K, and H, are located on the circle. If you search this on Google, you might also want to search cyclic quadrilaterals. That's another name for it. All right, let's start off with the idea that angle H here and angle R here are inscribed angles. If angle H and angle R are inscribed angles, they are half the measure of their intercepted arc. So if you're looking at the measure of angle H, it is going to be equal to 1/2 the measure of arc KRF. Okay. Angle KRF, or arc KRF, sorry, is this arc right here. Okay. So that goes with this angle here. The other angle, angle R, the measure of angle R is going to equal 1/2 the measure of arc FHK. And let me highlight that for you so you can see that as well. Let's do that in blue here. So this angle R here is an inscribed angle that has this intercepted arc, arc FHK. Now, if we treat this like an old-time addition, where we add from top to bottom here, we can say that the measure of angle H plus the measure of angle R is equal to 1/2 the measure of arc KRF plus the 1/2 the measure of arc FHK. Okay, so we're just kind of adding from top to bottom here like we used to do in grade school with addition. One thing I want you to notice about arc KRF and arc FHK is together they make up the entire circle. So if you want to look and see what the entire circle is, we can highlight that for you here. So let me highlight that real quick. Okay, so let me highlight that. Together, they make up the entire circle. Okay? Now, the entire circle measures 360 degrees. Now, we got to do a little bit of manipulation here with your formula. So I'm going to stick with the measure of angle H plus the measure of angle R is equal to, now notice that in this equation, both have a factor of 1/2. I'm going to factor out the 1/2. In other words, I'm going to take the 1/2 out of both of these, and I'm going to write them inside the parentheses. So measure of arc KRF plus the measure of arc FHK. Now, we just said that these two arcs together make the entire circle. So if their measures added together right here, if these measures added together make the entire circle, together they have to add up to 360 degrees. So 1/2 of 360 degrees is 180 degrees. Well, what does this mean? Well, if the measure of angle H plus the measure of angle R is equal to 180, they are supplementary angles. So opposite angles, of an inscribed quadrilateral are supplementary. Put a star next to that. So opposite angles of an inscribed quadrilateral are supplementary. So if we go back up to our picture up here, angles R here and angle H here are supplementary, and angle K down here and angle F up there are supplementary as well. All right, let's take an example. Pause it if you need to copy anything down. Okay, so here is an example. We have in quadrilateral ABCD, the measure of angle B is 81 degrees. Determine the measure of angle D. Okay, so let's fill in what we know. Here is 81 degrees. Determine the measure of angle D. Well, one thing you notice is that B and D are opposite angles in an inscribed quadrilateral. So the measure of angle D plus the measure of angle B must be 180 degrees because they are opposite angles in an inscribed quadrilateral are supplementary. Substitute in what we know, so the measure of angle D is equal to plus the measure of angle B, which is 81 degrees, is equal to 180 degrees. From here, we can solve for our measure of angle D by subtracting 81 degrees from both sides, and you get the measure of angle D is equal to 99 degrees. Okay? Please make sure you get this into your foldable. Okay, the next thing I wanted to talk about was inscribed triangles. I wanted to talk about this because there's a special case that happens. I know we said we were talking about quadrilaterals here, but we do have inscribed triangles as well. What I want you to notice is that the measure of angle B, so here's the measure of angle B, is equal to 1/2 the measure of arc ADC. Let me highlight that for you so you can see it a little bit better. Okay, so here's the measure of angle B right here. This is angle B that I'm looking for. It is an inscribed angle, which means it's half the measure of the arc that it intercepts. Here is the arc that it intercepts. What do you notice about that arc? Arc ADC is what we call a semicircle. How do I know it's a semicircle? Well, the two endpoints here and here in the picture are the endpoints of a diameter. And when they're the endpoints of the diameter, that means your arc is a semicircle. And a semicircle measures 180 degrees. So the measure of angle B is 1/2 of 180 degrees, which is 90 degrees. So angle B here in your picture is a 90-degree angle. To put this into words for us, so please copy down the sentence. If a triangle is inscribed in a circle, again, that means that each vertex is on the circle, and one of its sides is the diameter, the angle opposite is a 90-degree angle. Okay, so if you didn't get all that down, please copy that. I'm going to move on to the next slide. Here's an example of that theorem and how we might apply that. So it says in triangle ABC, and you notice that triangle ABC is an inscribed triangle. The measure of angle A is 55 degrees. So I'm going to put that into my drawing, 55 degrees. It says determine the measure of angle B. Angle B is down here. I'm going to put a little question mark there for us. Well, we know that a triangle adds to 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C has to sum to 180 degrees. Now I know the measure of angle A is 55 degrees. Measure of angle B is what I'm finding, so I know I don't know that. And angle C, you notice that angle C is an inscribed angle in which it intercepts a semicircle. So angle C is a right angle, so I'm going to put 90 degrees in for angle C. Those have to add to 180 degrees. So I get the measure of angle B plus 145, excuse me, 145, not 140. 145 degrees equals 180 degrees. Subtract 145 from both sides, and you get the measure of angle B is equal to 35 degrees.